are with Kaveh from Tobii Dynavox, and you have a very good, software which we were also going through in the morning. So tell us something about this.
Yes, so we are Tobii Dynavox. We are the world leader when it comes to eye interaction and eye control technology. This technology can be used in many different fields. For example, we can record where people are looking with their eyes, and therefore you can use this for analysis of how well designed your website is, how you put products in your shelf in a supermarket, etc., etc. But one of the biggest applications is for people with various disabilities. So since we know where you're looking on the screen, that we can allow people that have limited hand movement or have no ability to speak to use their eyes as a pointing device to select things, to access the computers, to look at symbols for speech or text for speech. So it essentially becomes a speech generating tool. It becomes a replacement of keyboard and mouse if you're not able to use your hands and fingers or touch. And it becomes an tool for independence. So it allows people with various physical and cognitive disabilities to access computers and to create speech.
So can you just show us something how it exactly works?
So the way it works, and it's the same on this device that it is on this device. It has two cameras and two illuminators. We send near infrared light to your eyes, and we are constantly taking pictures from the reflection that is created on your cornea. By this, we can calculate where on the screen you're looking. So the idea is that depending on your cognitive level, we will give you an interface that will allow you to express yourself. So if you have an individual with, let's say, severe cerebral palsy, they are likely going to use an interface with symbols. So they will look at a symbol, and then that symbol that they look at will generate a voice. We have an example in the background, Ganga from Shishur Savai in Calcutta. She has cerebral palsy. She has an interface where she can look at different icons, and then these icons will express a voice because she cannot talk herself. So this becomes her only way of expressing herself. So she looks into on the computer screen. The camera inside the eye tracker reads her eye movement. When she looks at a symbol, that symbol generates a voice. So that's the purpose for somebody who is using symbols. On the other spectrum, we have adults who may be out of injury or a disability that they are born with or acquired, somehow suddenly cannot use their hands or are totally paralyzed. For example, like Dr. Stephen Hawking, that's somebody that has ALS. Those kind of users already know how to use a computer. They just have to learn how to use it with their eyes. So those individuals, of course, are not using symbols. They are rather using on-screen keyboards where they can look with their eyes and type different things and post into Facebook and write emails, be on Skype, make SMS and phone calls, basically be independent the way they were before the disability or before the injury that they acquired. So the range of people that used eye control or eye interaction is anything from 12-month-old babies with severe disabilities that just want to learn how to point, or the parents want them to learn how to point with their eyes, up to adults with an acquired disability who just need an alternative way to access a computer.
So this is an application which can be used by any person, right?
Yeah, I mean, we are not discriminating in terms of age. The only needs is that either you don't have hand movement, or you don't have any hand movement nor speech. These are the kind of user groups. Of course, if there's a cognitive disability as well, we have to practice. You know, there's a learning curve that needs to be in place before the user can actually learn before they understand that if I look at something, I can make the computer say something for me. And this is a barrier we have to pass, of course, but that's something we have software specifically made to overcome this. Because if you're a child that has never been able to access anything, you have no idea what a click or double click means. We need to establish this relationship between your eyes and the computer. So there we have developed software for specifically these tasks to teach children how to point with their eyes. Once this is established, you can give them more and more advanced symbol options, or even they can become literate. But yeah, for somebody who has never been able to access anything, this is where you start. And I will show you some example of that.
I would really want to see that.
So right now I'm just positioning myself in front of the screen, and as you can see, I can move my head. It's still following my eyes. I can go backwards, I can go forwards. The cameras are still able to track my eye movement. So I'm going to show you a couple of these games that I mentioned that are made for teaching eye movement or teaching eye pointing. So when I look around the areas of the screen, I paint. So this is sometimes the absolutely first interaction a child might have had with a screen or with a computer. So when they look at the different part of the screen, a color appears. So it's about cause and effect. It's about teaching them that they can manipulate a screen. They can make things happen on a screen. Um, then there's a bunch of activities made for this purpose. So when I look at the different smileys, they will explode. So I learn how to pursue things with my eyes. So wherever I move, you see the cursor, that's my eyes moving. Okay? I'll show you something else. How many people ask me, how do you click? Is it by blinking? That's one way to do it. But the most typical way to click on things is actually to dwell, to focus on something, and then you make a click. So by looking in an area and focusing my gaze, I actually can select something. We introduce also grid-based pages, so they learn how to, if they stay inside one of these boxes, they get a reaction. So we have the apple. So this is a memory game, but it's also practicing to concentrate your gaze, to stay inside these boxes to make something happen. And I'm doing all of this with my eyes. Eventually, the goal is to take them to a symbol interface. So I will show you one example. For example, here, if I want to create a sentence, I look at I, and then I look at want. Now what do I want? Maybe I want a toy train.
I want toy train.
So it becomes text to speech. I create a sentence and then I tell the computer to speak this for me. It becomes my voice. And then of course we can give them more and more advanced symbol-based vocabularies as they develop. And hopefully, I mean, the goal is to bring some of the kids to literacy, and we have kids that have been able to do that. Also, as I mentioned, we have some users that from the start already are literate. They just don't have a proper access method. So they might be using something like this. If I want to just write hi, I look at H, then I look at I, space, and then look at M. There's no Y in this keyboard. I think it's a Hungarian one. So anyway, if I want to type something, let's type my own name. So I write hi Kaveh. If I look at the speech,
Hi, Kaveh.
so this is how a literate person or an adult or somebody with a acquired disability will use to type things. Having said that, I mean, it's not only about typing or expressing things. There are also a lot of different arenas. Like one area where people with disabilities actually are very much included, if they have the right access methods, is social media. So if I give somebody with a physical disability a way to post things on Facebook, of course, then they are a part of the social media community.
Yeah.
So it's actually a very good tool for inclusion if people are able to use Skype, to use Facebook, to use email, etc. So, as I mentioned, the range is anything from really small babies who are born with a disability and the parents are, really want to find ways for them. When normal children point at things, we gave them labels. We teach them words. They point at something and we tell them what that object is. The same way with children with disabilities, you can start with those simple games that I showed you to teach them how to point with their eyes. Eventually they will start to use symbols to express more and more complex needs, and hopefully we can also get them to literacy. And on the other end of the spectrum, you have adults, people with injuries, disabilities that are just want another tool to be independent, another tool to access computers.
Thank you so much, Kaveh.
You're welcome. My pleasure.